So if you have version A, question number 10 says, a force of 10.6 newtons is applied to an object of mass 1.4 kilograms. So you need to find, version B people, you need a little help with the person beside you. You need to find the question number that matches that in version B. So the question is, a force of 10.6 newtons is applied to an object of mass 1.4 kilograms. It's question 13, I'm told. Okay, and what is the first, instead of 10.6 newtons, Christine, what is the value? 10.9. Okay, so listen, if you have version B, you cross out the 10.9 and you write in 10.6, and then your answers will, the ones that I'm going to write down, will match. If you have version B, I'm going to go through, it's up to you. It's up to you. I'm going to go through the version A solutions. If you want your numbers in the question to match the solution, you're going to have to do this. Cross out the values in the question and just change them so that it's a question A numbers.
Wait, so what's the answer to number 10?
I have, no. So the question reads, a force of 10.6 newtons is applied to an object of mass 1.4 kilograms. It accelerates at 1.6. Determine the force of friction that is acting and the coefficient of kinetic friction involved. So this 10.6, that is our applied force, 10.6.
Wait, what?
The mass is 1.4 kilograms. The acceleration is 1.6. You are determined the force of friction and the coefficient. Okay, so we've got, this is a horizontal force question, right? We've got an FA and we've got an FF. So the first step is to find the net force, mass times acceleration. 1.4 times that 1.6, which is 2.24, is our net force. Right? That's based on what we know about the mass and acceleration. Then F net is equal to FA plus FF. 2.24. The applied force is this value, 10.6, or 10.9 if you have the version B. And we're going to solve for FF. And at this point, I expect you guys to be able to solve this. This should be like automatic. Minus 8.36. Okay? Then you find the weight force. 1.4. Gravity is minus 9.8. Minus 13.72. And then your mu value. And I have to speed up so I can get this done in this period. 13.72. Okay? And that is worth 1, 2, 3, 4 marks. Alrighty. So question 11 on A. Help me out, version B people. 11 and 11? Oh, that's convenient. A truck is pulling with 2950 newtons on a 590 kilogram trailer. So once again, make those adjustments there. The applied force is 2950 newtons. The mass, 590 kilograms. Pulling it horizontally across the surface where the coefficient of friction is 0.2. So again, it's a horizontal type situation like so. We know the mass. Let's find the weight force right off the start. 590 times 9.8. 5782 newtons. Right? And is that, that's actually technically negative, that makes the normal force 5782 upwards. Yep. 590. Now we're going to go with mu equals FF over Fn. Our mu value is 0.2. Solving for FF. 5782 is your normal force, giving you a friction force of 1156.4 newtons. Okay, so part B determines the trailer's acceleration. Before we can get acceleration, we're going to need the net force. It is the applied force plus the friction, right? These are the two forces that are acting on it. We don't worry about the y's, y components. So our applied force is that 2950, and our friction force is negative 1156.4, giving us a net force of 1793.6 newtons. Whoa.
This is 2950 plus -1.
Yep. Because it's a friction force. It's automatically in the opposite direction. Right? So now that we have our net, we can find our acceleration. 1793.6. The mass is 590. And again, you've got to be able to solve these. Divide by 590. 3.04 meters per second squared. A, Josh, 590A. F net equals M A, right? Number 12, right? So A is number 12. Have B people figured it out yet? How much force would be required to start a 4.1 kilogram object sliding? How much force would be required to start a 4.1 kilogram object slide?
Yeah,
10. Excellent. Okay. So the mass again, 4.1. And the coefficient is 0.18. These are all kind of the same kind of question, aren't they? 0.18. So, first step, FW is equal to mg, 4.1 minus 9.8. Got a weight force of 40.18. Therefore, actually it's negative. The normal force is that 40.18. Mu equals FF over Fn. The mu value is 0.18. We're solving for friction. Normal force 40.18, giving us a friction force of 7.23 newtons. That's how much friction is acting. And it says how much force would be required to start it. So you would need an applied force that is greater than 7.23, right? Slightly greater than 7.23. Any force bigger than 7.23 would accelerate. No, it's, I mean, it's number 13 in A is the 1.6 kilogram object is dropped from 6 meters above the surface of the moon of Jupiter. 12. So B is like number 12. Okay, now this is a moon of Jupiter. It is not our moon. It is not the Earth. You cannot use 9.8. It's a completely made-up planet. Okay? So what do we have? We have a mass of 1.6. The distance it's dropped from is 6 meters. And the time is 2.66. And it asks for the acceleration. Okay? The only thing you can get out of those three values there, d and t, is the average velocity. And average velocity is distance over time. So that's going to be 6 over 2.66, which is 2.26 meters per second. 2.26 meters per second. Now, if you have this on your sheet, if you have V bar is not equal to delta V, you need to seriously think about this. What does this mean? Okay? Because here's what you're doing. Let's say you got a 70 on your first test and then a 65. How mad would you be if I said your mark was -5? You'd be pretty mad. That's what you're doing. Because you lost 5 marks, right? What's the average? This is the change in mark, delta M, and the average mark would be 67.5. They are different. They are not the same. Stop making them the same. Okay? Some people, if you've got V bar equals delta V, not equal to delta V on your page, that's what you're doing. Stop doing it. Find out what you're doing wrong. Okay, so that is the average velocity. So then you would write V bar equals VI plus VF over 2. The average is 2.26. What's the initial velocity when you drop something? 0. Right? And you're going to multiply both sides by 2. And again, you got to have these math skills, you guys. 4.51 meters per second. And you really should have something like this. And I guess really, this should be -6 because it's being dropped. So that should be negative, which makes that negative, which makes that negative, which makes sense because it's falling, right? But when you put a 0 in there, what is the final velocity? Right, it's the same number. Is the, oh, hang on here, I screwed up, didn't I? Yes, I did. I went backwards here. Let me go back here. This number should go in for the VF, right? What I'm trying to say is that the change in velocity is minus 4.51. Right? That's how much the velocity changes. It goes from 0 to minus 4.51 as it drops. And then you go into here. And the time, and you get an acceleration of 1.7 meters per second squared, negative. So Raston, here on Earth, the acceleration is minus 9.8. On this unknown moon of Jupiter, what is the acceleration of gravity? You can tell me, it's right up there. Okay, stay with us, man. Stay with us. Minus 1.7. So this moon is considerably smaller than the Earth. Yep, I know. That's only Earth's moon. This is Jupiter's moon. What is the value of force of gravity? Here's where you go Fw is equal to mg, and lots of people put 1.6 in there. They remembered me saying that that's the gravity on the moon, but that's not what we're talking about here. We're talking about this moon of Jupiter. So it's that mass of 1.6 and then times minus 1.7. So the force of gravity here, 2.71 newtons. Not on Jupiter, on this moon of Jupiter. This is the acceleration of the moon on Jupiter, and that's equivalent to 1.7 newtons per kilogram too, isn't it? Right? Got lots more to do here, don't we? Ready to talk Boy Scouts? Thank you. The Boy Scouts is question number 14, which is question 15 on B. Okay. Here's where you have to have seen a question like this. You have to know that the time up plus the time down is a total of 6.5, which means that the time up is just 6.5 divided by 2, or 3.25 seconds. You have to divide the time first. Then A equals delta V over delta T. Here now you can use minus 9.8 because the Boy Scouts are on Earth. Our time is 3.25. And you get minus 31.85 meters per second. That's how much the velocity changes. Now, if it changes by that much, and the VF at the peak is 0, that tells me that the initial velocity is positive 31.85. Right? And now you can go to your average velocity formula. $15.925. And we're trying to find the height of the tree. And the only one with height of the tree in it, the only one with D in it is V bar. That's why we had to find that V bar in this step. 15.925 is equal to displacement over the time, which is 3.25 seconds. And our displacement is 51.76 meters. That's a pretty big tree. That's half a football field. He's got a heck of an arm. Some of you came up with a tree that was 100 meters tall. The guy's got like a rocket launcher for an arm. Go ahead, Josh. 31.85? VI? Therefore VI. 14? Okay, 3 questions left. Number 15. In B, it's number 14. This is the guy on the elevator, right? Okay. In version A, the elevator is coming to the bottom, which means he's going to weigh more. I think in version B, he's going to the top, which means he weighs less, right? Okay, so you would write FWA, apparent weight. FWA, weight force plus mass times acceleration. So he has a mass of 71, gravity minus 9.8, or 9.8, and again his mass, and this time it's 2. You add them together, he weighs more. 837.8 newtons is how much he weighs in newtons. If you have the other version, it would be a subtract in here. He'd weigh less. And then you have to convert that to kilograms. So that's going to be 837.8. And you divide by 9.8 to get it in kilos. 85.5 kilograms. And I wasn't recording there. Not good. Well, too bad for those people that are away, I guess. Sorry, Zach. Adam. Callan. You got him? All right, part B. How far has the wallet fallen? Before you can find distance, you need to find average velocity. VI plus VF all over 2. Initial 4.2. Final minus 68.32. Sorry, I guess it really should be plus negative 68.32. And you're going to divide by 2. So you get minus 32.06. That's the average velocity. And then you can plug it into this one. Time. How much time has he dropped this wallet? 7.4 seconds. 237.2 meters. His wallet's fallen a long way. Now you remember, just like in Kyle and the helicopter, the balloon is rising. How fast is the balloon rising? At 4.2 meters per second. Right, so how far does it go? So the balloon goes up 31.08 meters, and then you have to add them together because the balloon goes up and the wallet goes down. Yes, dt, total displacement, total distance. The wallet is 268.28 meters below the balloon. Hang with me here. Last question. This one is number 17. I believe it's number 16 if you have the other version. This is a long one. Hang in here with me. 17A, 16B. (150 newtons), angle is 27 degrees. Okay, settle down, you guys. Pay attention. 0.18. And it's 22 kilograms. Okay. Guaranteed, again, on the exam. Guaranteed. You must understand this question. Okay? The force is applied at some angle, and it's broken into components. FAX and FAY. X and Y components. X meaning left and right, Y meaning up and down. Okay? Many of you did this. FAX is equal to FA cos theta. 150 times the cosine of 27, and you get 133.7. Lots of you did that right. 133.7. The angle is 27. That's how much of the force actually goes sideways. (150 times the cos of 27). I don't know, man. You also have to find the y component, FAY, which is FA sine theta. 150 sine 27, or 68.1. You have to see the end of it before you can, yeah. You'll see why. Okay. Normally, the normal force is equal to the, normally the weight force and the normal force are balanced, right? But in this case, there is also an upward component, which is FAY. Some of this force goes into doing what? Lifting up. Okay, so you've got FAY up and you got FN up, and that's balanced by FW. And the way I showed you to write that was that the net, the overall net Y was equal to 0, right? up and down, it's balanced. The overall net y is 0. And then F net y is made up of normal force plus FAY plus the weight force. Right? FAY is the y component of the applied force. How much of that 150 actually lifts up? F net y. Yes, we went through it, Jaden. I can show you where. Guaranteed. I guess you weren't. That's why I post the videos. So, what is the weight force? We don't have it yet. mg. Mass is 22 minus 9.8. Now, does the minus here matter? Yes, it sure does. 215.6. $215.6. Yeah. Do not think you're going to just look over your stuff the night before for this exam. 25% of your mark. I'm not trying to scare you. It's just reality. Okay. No. Well, this is hard. Yeah. Okay. We are solving for the Fn. The FAY is 68.1. And the FW is minus 215.6. Take everything to the other side. 215.6 subtract 68.1 is our normal force. And you get a normal force of 147.5 newtons. So the normal force is significantly less than the weight force. Many people, I wrote this on your tests. If I wrote Fn not equal to Fw when FAY is greater than 0. If you have that on your test, it's because you didn't do this step. No? No, I want to keep going. I want to keep going, Jade. No, you can keep it. You can keep it. Okay, next step. Mu equals FF over Fn. Mu value, 0.18. FF, the Fn is 147.5. That's this number right here. FF is going to be, you're going to multiply and get 26.55 newtons. Yeah, it's about the TED Talk. Okay, now, horizontally, what forces do we have horizontally? Horizontally, we have FAX, we have friction force. No? Raston, stay with me, man. Stay with me. The net force horizontally is made up of FAX plus FF. And the FAX was 133.7. And the FF is going to be plus a minus 26.55, 107.15 newtons. Takes practice. If you haven't done the problems, you're not going to see them. Now we got our net force. Now it's a simple matter of going F net is equal to MA. What's negative, Josh? No, because it's 133.7 plus negative 9.6. Okay. 4.87 meters per second squared.